Hello, everyone. Welcome to my channel. This channel is dedicated to educational matters of the relatively esoteric and obscure. Mostly people who are my heroes, who put their whole life into something, into a project, into uncovering, it's coming closer and closer to the truth about things, especially in terms of cosmologies or theories of everything. But at the end of the day, um, nobody really paid too much attention to their work, and they didn't get famous, they didn't make any money, and their theories didn't really get out there very much. Um, One of the main people on that list for me is Mr. Dewey B. Larson. And Mr. Larson is the author, discoverer of the reciprocal system of theory. And this is a theory, system of theory, a theory of everything that you can plug into any subject that you like. Mr. Larson wrote books on physics and astrophysics, chemistry and astronomy, and psychology, religion, metaphysics, including things like dream interpretation, economics, and a few of his followers have written books on many other subjects as well. The basic idea behind the reciprocal system of theory is that we live in a universe of motion, not a universe of matter and not a universe of energy. The fundamental component of the universe is motion, and motion is the relationship between space and time. Space and time, therefore, are not the container of the universe, but they are the contents of the universe. And space and time have a generalized reciprocal relationship. Basically, motion is a fraction with space or time as the numerator and time or space as the denominator. But time and space can come in 1, 2, 3, or even more dimensions. That's what Larson calls coordinate space and coordinate time. And time and space can also have their progressing aspects. Larson calls that clock space and clock time. Time on the clock is always getting later and later and later and later. And so too, space on the clock is always getting farther and farther and farther apart, which you would envision using a balloon and putting a couple dots on it with a magic marker. All of the dots are moving away from each other if you blow up the balloon. If you suck in the balloon, all the dots are moving toward each other. This is respectively outward and inward scalar motions. Scalar motion is a motion that has a magnitude, but it has no direction. Space and time also only come in discrete units. There is one minimum unit of space and a minimum unit of time. That's 1 unit. And 1 unit of space in 1 unit of time is the speed of light, which leaves the speed of light as the background or the origin of the universe. Whereas Einstein thought that the speed of light was the maximum speed of the universe, in Larson's universe, the speed of light is the midpoint of the universe, or the null point, or the reference point, the natural reference system of the universe. And there is an entire half of the universe that is actually moving faster than the speed of light. Larson calls that the cosmic sector. And then there is the half that we're familiar with, called the material sector, that's moving slower than the speed of light. That's the half that Einstein understood when he said that nothing moves faster than the speed of light. But in the cosmic sector, nothing moves slower than the speed of light. Now, this cosmic sector is a mystery, or has been a mystery to us, but with the reciprocal system, because of the reciprocal postulate, we can extrapolate what we know about the material sector through all of our observations and measurements. The exact same thing is going on in the cosmic sector, except that the roles of space and time are reversed. So we actually know a great deal about the cosmic sector, but we just don't know it yet because we haven't understood the reciprocal system. Now, in Larson's system, there's basically four different kinds of motion. You have a translational motion, you have a vibrational motion, you have a rotational motion, and you have a rotational vibration. And these motions can occur in one, two, or three dimensions, and they can combine with one another in certain combinations. I guess the most understandable combination right off the bat, or not understandable, is the photon. And the photon is a simple harmonic motion, which is a wave-like motion. Larson says that the simple harmonic motion is a combination of a translational motion and a vibrational motion 90 degrees apart from that. And you combine the two and you get a sine wave. Some of Larson's followers have disagreed with that and said that this it is a result of a birotation. You combine two counter-rotating motions and you also get a sine wave. The sine wave, the birotational model seems to answer more questions. It seems to make more sense to me. But we will go over the differences and compare those two different points later on in the development. So right now we're with Larson, where he's talking about the photon as the vibration of an already existing translational motion. Now, you can combine these things even more. So once you have the photon, then you can rotate the photon in a number of different dimensions, in a number of different directions, and you eventually create subatomic particles and atoms. And that's what we're looking at right now. This is Larson's 1979 book called Nothing But Motion. And we are in chapter 10 of this book. This book mainly covers physics and astrophysics, physics and organic chemistry. And we're in chapter 10 called Atoms. He had just gotten done explaining kind of the noble gases of the periodic table and how they are, an atom is really his notation is a three motion notation, A dash B dash C, and A and B are both two-dimensional, what he calls magnetic rotational motions, and then C is a one-dimensional electric rotation. And the noble gases are the elements that have numbers for the first two, A and B, but the C is a zero. And the C, the electric rotation, is what fills in the gaps between the noble gases. And that's about what he's about to start talking about right here. The number of mathematically possible combinations of rotations is greatly increased when electric displacement is added to these magnetic combinations. But the combinations that can actually exist as elements are limited by probability considerations. As noted in chapter 9, the magnetic displacement is numerically less than the equivalent electric displacement and is more probable for this reason. Its status as the essential basic rotation also gives it precedence over the electric rotation. Any increment of displacement consequently adds to the magnetic rotation if possible, rather than to the rotation in the electric dimension. This means that the role of the electric displacement is confined to filling in the intervals between the inert gas elements. On this basis, if all rotational displacement in the material system were positive, the series of elements would start at the lowest possible magnetic combination, helium, which is 2-1-0, and the electric displacement would increase step by step until it reached a total of 2n squared units, at which point the relative probabilities would result in a conversion of these 2n squared electric units into one additional unit of magnetic displacement, whereupon the building up of the electric displacement would be resumed. This behavior is modified, however, by the fact that electric displacement in ordinary matter, unlike magnetic displacement, may be negative instead of positive. The restrictions on the kinds of motions that can be combined do not apply to minor components of a system of motions of the same type, such as rotations. The new effective rotation of a material atom must be in space in order to give rise to those properties which are characteristic of ordinary matter. It necessarily follows that the magnetic displacement, which is the major component of the total, must be positive. But as long as the larger component is positive, the system as a whole can meet the requirement that the net rotation must be in space, positive displacement, even if the smaller component, the electric displacement, is negative. It is possible, therefore, to increase the net positive displacement a given amount either by direct addition of the required number of positive electric units or by adding a magnetic unit and then adjusting to the desired intermediate level by adding the appropriate number of negative units. Okay, so that you can kind of illustrate if you look at maybe the second line of the periodic table where you're going from helium up to neon, and so helium is 210. So 211, helium is number 2, element number 2, and then you add 1 and you get lithium. You add another one to get beryllium, and another one to get boron. So boron is 213. The next element is carbon, 214. But he's saying that then the next element, nitrogen, number 7, you could say it would be 215, but more than likely, statistically, what it actually would be 2 negative 3. So you would go all the way up to neon, which is 220, and you would subtract 3 from that. Neon is number 10, element 10. So then you would subtract 3 from that to get down to nitrogen. So, and same with carbon, where carbon is 214, but carbon also has an alternate form that is 2 negative 4, because it's right in the middle there, and the probabilities are approximately equal as to which one of those would form. When you get up to nitrogen, is more probable that it would take the negative, that the third number would take a negative 3 than the positive 5, because small numbers are more probable than large numbers. So, to complete that, then you would have oxygen as 2 negative 2, and fluorine as 2 negative 1, and then you're back up to the noble gas neon, 220. Okay, so that's kind of what he's saying there. Which of these alternatives will actually prevail is affected to a considerable degree by the conditions that exist in the atomic environment. But in the absence of any bias due to these conditions, the determining factor is the size of the electric displacement, lower displacement values being more probable than higher values. In the first half of each group, intermediate between two inert gas elements, the electric displacement is minimized if the increase in atomic number, equivalent electric displacement, is accomplished by direct addition of positive displacement. When n squared units have been added, the probabilities are nearly equal. And as the atomic number increases still further, the alternate arrangement becomes more probable. In the latter half of each group, therefore, the increase in atomic number is normally attained by adding 1 unit of magnetic displacement and then reducing to the required net total by adding negative electric displacement, eliminating successive units of the latter to move up the atomic series. By reason of the availability of negative electric displacement as a component of the atomic rotation, an element with a net displacement less than that of helium becomes possible. Adding 1 negative electric displacement to helium produces this element, 2, 1, negative 1, which we identify as hydrogen, and thereby, in effect, subtracting 1 positive electric unit from the equivalent 2 units above the rotational base that helium possesses. Hydrogen is the first in the ascending series of elements, and we may therefore give it the atomic number 1. The atomic number of any other material element is its net equivalent electric displacement. Above helium, 210, we find lithium, 211, beryllium, 212, boron, 213, and carbon, 214. Since this is an 8-atom group, the probabilities are nearly even at this point, and carbon can also exist as 2, 2, negative 4. The elements that follow move up the atomic series by reducing the negative displacements. Nitrogen, 2, 2, negative 3. Oxygen, 2, 2, negative 2. Fluorine, 2, 2, negative 1. And finally, the next inert gas, neon. Another similar 8-element group follows, adding a second magnetic unit in the other magnetic dimension. This carries the series up to another inert gas element, argon, 320. So you fill in the gaps there. So you start with 220 neon. So then 221 is sodium, 222 is magnesium, 223 is aluminum, 224 is silicon. But silicon can also take the negative orientation of 3 to negative 4, because 4 and negative 4 are the same magnitude, so they have approximately the same probability. And then I would think it's a slightly lower probability because the 3 number instead of the 2 number as the first number. Then you have phosphorus as 3 to negative 3. 3 to negative 2 is sulfur, 3 to negative 1 is chlorine, and 3 to 0, again, is argon, back to the noble gas, inert gas at the end of the column. So that's kind of how the periodic table is constructed in Larson's system. You have a 3 number grouping there. The first two are we have the primary magnetic rotation, and then you have the secondary magnetic rotation, and then the third number is optional, but it is the electric rotation. And that third number is what fills in the gaps between the inert gas elements. So at element number 18, argon, the magnetic displacement has reached a level of 2 units above the rotational base in each of the magnetic dimensions. In order to increase the rotation in either dimension by an additional unit, a total of 2 times 3 squared, or 18 units of electric displacement are required. This results in a group of 18 elements, which reaches the midpoint at cobalt 329 and terminates at krypton 330. A second 18 element group follows, as indicated in this table that he has. The final two groups of elements contain 2 times 4 to the second power, or 32 members each. The heaviest elements of the last group have not yet been observed, as they are highly radioactive. This is, in Larson's periodic table, goes all the way up to number 118, or at least 117. But the ones that we've observed in the laboratory, I think, only go up to 105 or something like that. But he says that these other elements exist, but they're highly radioactive and consequently unstable in the terrestrial environment. Okay, we'll leave it off there and start up again tomorrow. Thanks for tuning in, and have a great day.